Thank you for joining this Quantum Security Defense webinar. Are we there yet? Finding the way on the rocky road to a quantum-safe infrastructure. Since 2013, Stefan-Lukas Gazdag has focused on post-quantum cryptography, PQC, and future-proof security mechanisms, overcoming obstacles in practical use. He is part of the research group at German IT security company GenUA. With his team, he works on publicly funded PQC research projects and other collaborations, enabling the transition to quantum-safe networks. He was, for example, involved in the publication of the first explicit PQC RFC, RFC 8391, describing the signature scheme XMSS, recommended, for example, by US, NIST and NSA, German BSI and other agencies. His work has been applied to the real world on several occasions. For example, hybrid post-quantum software updates and a hybrid post-quantum VPN solution for genua products, both authorized by German BSI for use with classification levels German VSNFD, NATO restricted and Restraint EU restricted.
Hello to everyone, wherever you are and whatever time it is right now for you. So my company dived into post-quantum crypto about 15 years ago. So we were just kind of curious, what can quantum computers actually do? So then we talked to people about post-quantum crypto, which was quite a small community at the time. Later on, we talked to QKD people. And now I want to invite you to a little journey from academic results to what does it need to actually apply something to the real world out there. So let's start with this let's call it a pyramid scheme. So what you see is a lot of academic research, and it's really continuous output. There's more and more, there's new knowledge, there's people applying something on recent results, and this goes on and on. So we really have a lot to see there. And at some point, you need to bring it into practice. And usually what you talk about first is protocols, because if you imagine a crypto scheme, you can't just really use it on its own. So you will need to apply it to a communication protocol or to an application. And at first, you're also talking about concepts, but later on, you've got to think about how do you implement it? What does the code look like? And will it be practical? Can practitioners actually use your code? Or will it just, be too slow? Or will it stand in everyday use? And then you have a lot of things surrounding that. So you have different kinds of standardization bodies, and they have, let's say, different kinds of flavors, different philosophies. Then there's regulation. So you have NIST, which is now very well known with the post-quantum crypto standardization process, but you also have other agencies. And as much as a lot of these agencies cooperate or talk to each other, there's also different views on what you should actually do. So somehow you got to get from this academic research to actual practical use. But how do you do that? And everything begins with ideas. Here, this is from a paper. So imagine some smart people tell you we need to rethink how we do key agreement. For post-quantum crypto, for QKD, we need to rethink what we did a few years ago way differently than we should do today. And then they propose a scheme a concept that they call ML-KEM. And then other people will pick it up and they will say, okay, we think we can improve it. And then they provide you with ML-KEM Plus. And then other smart people will take this idea and say, yeah, but maybe we can focus on a specific aspect of that. And then suddenly you have ML-KEM Sharp. So there's a lot of work going on and it's really interesting. But where do you start? So if you say okay, now I want to apply this to practice, what do you take? Do you start with ML-KEM, with ML-KEM Plus, with ML-KEM Sharp? Are you gonna wait for ML-KEM HD Plus, whatsoever? And the good thing is, luckily enough, what we actually needed is a vision. So what we do understand is we need this fusion reactor for different kinds of crypto schemes to include pre-shared keys, to include classical crypto, post-quantum crypto, QKD, whatsoever. It has to be fused together in the future. So this is our vision. But if we take a look at what's already there, because we can't just always invent new protocols, we kind of need to apply to the world outside, like what's actually being used. And this, for example, is the Internet Key Exchange in version 2, and this is usually used for IPsec-based VPNs. And what you can see here is like a classical crypto protocol. So the so-called initiator will send a packet to the responder telling, hey, I want to communicate with you. I want to establish a secure tunnel to you. And here's a proposal for what crypto I'd like to use. And if you're fine with my favorite crypto, here's also my key share. And we hope that the responder will simply say, okay, yeah, I want to talk to you. Your favorite crypto is just fine. Here's also my key share. So if that happens that way, then they can actually encrypt the following communication. What they don't know yet is, are they talking to the right person, or is there a man or woman in the middle?
Thank you for watching this preview. The entire presentation and over 150 quantum and advanced AI presentations from industry leaders are available on QSECDEF. Search for Quantum Security Defense to find out more.